is how Medium uses Neo4j, and this is a little bit about me. I'm Nathaniel Felsen. I'm a DevOps engineer at Medium, and you can see on that slide all my contact information. So if you ever want to ask me a question privately, you can contact me via LinkedIn, email. You can follow my writing on Medium at Felsen. And then you can see a picture of me on the right, the same that's on the webinar snippet. So if you ever see a dude like that in the street of San Francisco, you can come by and say hi. That picture might be a bit confusing because I usually don't drink pina colada with pink umbrella. It's going to be looking more like this, I would assume. So if you see a guy with a beer that looks like me, it's definitely me. So come by and say hi, and we can talk more about Neo4j. As Adam said in the introduction, the agenda is the following. I'm going to briefly talk about what Medium is, and then what we do with Neo4j business-wise. And then I'm going to explain how we went on picking Neo4j over competing solutions. I'll briefly talk about our architecture in and out. And then I'll talk about how we went from having Neo4j running inside our internal environment to going live with it. And then the lesson learned from using Neo4j in production for about a year. And I'll conclude the webinar with a demo. So without further ado, let's get straight into what Medium is. And that's probably like the hardest part for me to explain, because that's the one that's the most confusing when you have to, when you really have to explain how cool Medium is. So basically, Medium is a new publication platform. It's about 2 years old, and the idea is like we're trying to improve the quality of the content on the internet by providing a good publication platform for lengthier content. And so anyone who had something to say that was more than a tweet could just get there, write their stories, and push that to the rest of the world. There's kind of nothing new in that, except the fact that it's more, centralized around one platform versus, everyone having their own blogs. So if you think about it, in the first era of the internet, like you would have companies like Blogger, for example, allowing you to create your own blogs, and then you would basically try to gather your own audience and have them to come every now and then on your blog and read new content. And then more recently, with the appearance of social network sites, it's been a little bit different, where people just try to write wherever the public is and just try to broadcast that through those social behavior to everyone out. So this is kind of what we are trying to achieve with Medium. We create that platform that's really awesome when you want to write something or when you want to read something, and we're trying to basically add a social layer on top of it. So Medium is becoming more and more popular, and here are a few people who are considered as influential contributors who are writing on a regular basis on Medium. And so it's kind of cool when you think about it, right? Because that means that to some extent, people like Barack Obama have used Neo4j as a user. And this is how organization also are using Medium to let people know about their ideas. And I actually had that slide in the slide deck because I actually got those first few slides from Sol. So thank you, Sol, who's a biz dev at Medium. And in fact, the really cool thing about those slides is that those are the real actual slides that I shows to everyone to do business. And the best part is the following slide, which is this one, about how Medium is a network that builds audience. And so the idea is, like I said, when you're on the platform, you have the ability to follow a writer, to share a story, to recommend. And through doing those actions, you're going to basically influence an algorithm that tries to figure out what you would like to read next. And that's going to personalize your reading list, basically. And that's also going to help us sending you targeted emails with content that you're more likely to like. And as you can see through that, what we are doing is basically adding a social graph on top of the platform. And whenever you hear a graph, you can imagine that Neo4j is a good solution for it. And this is exactly what we use Neo4j for. So let's see how we ended up using Neo4j, picking Neo4j. When we had a data selection process to implement that social layer on top of the platform, it was roughly about a year ago. We went through a couple of different ideas. And actually, to be honest, Neo4j was our first idea, but for the sake of the webinar, I'm keeping it for the last option, so we keep the suspense. So the first option I'm going to talk about was how we could have done it using DynamoDB. One thing to know is that Medium is hosted on Amazon Web Services, AWS, and so we use heavily DynamoDB. That's our first and main storage. So all the content that you see, that you read on Medium or that you write on Medium is basically backed by DynamoDB. Plus, we use that to store all your all the detail about your information, like name and email address and things like that. So for us, that would have been kind of an easy way to use. That would have been a good solution to use DynamoDB because we already were using it, so we knew how it works. And then we had basically no maintenance added to what we are currently doing, since Amazon is owning the service, and it's like a how do they call that again? A managed service, so you don't have to do anything for it, and you don't need to add any hardware to your infrastructure. The problem with DynamoDB is that in order to make good use of DynamoDB, you need to know pretty much the schema ahead of time that you want to come up with, because that will greatly influence the performance of DynamoDB. And so when you're at the experimentation stage, and you're looking at what you want to do, and without knowing exactly what feature you want to implement, which feature will have traction or not, like it's very hard to do that with DynamoDB, because it's very hard once you start having data in your table to make any changes. So it wasn't easy as a solution to use that for experimentation. Also, like as mentioned in the slides, it's a little bit more complicated to query data, and going through a graph, for example, require many queries, so it's probably not going to perform very well. So we didn't go with DynamoDB, obviously. The other good option we were thinking about was to simply use something like MySQL. On Amazon, that would have been your RDS, so we didn't have to also manage hardware. But it has lots of pros and some cons as well. On the pro side, that even so, on the pro side, first of all, everyone kind of know MySQL. You've learned that at school. You've used that in your previous work experience. It's kind of rare, the companies that don't use any SQL, any relational database in their infrastructure. So you probably know how to do most of it, and you know that if you want, for example, a person to be part of multiple groups, you just use 3 tables, one for person, one for group, and then a person group table to do the union of those 2 tables. So it's not impossible to do, but it doesn't feel too right to implement a graph database on top of a relational database. And then we're kind of worried that because of the idea we had around importing your social graph from Facebook and from Twitter, that the graph, like the database, would be pretty big. So we'd have to almost from the get-go think about creation of sharding, which is never an easy thing to do, and that's really not where we wanted to spend time at that time. So we decided to not go with any kind of RDS system. We are also briefly thinking about FlockDB. So one thing I didn't mention yet is that Medium has been co-founded by Ev Williams, who prior to that co-founded Twitter, and prior to that actually co-founded Blogger. So FlockDB was an interesting option because there's a couple of people who came from Twitter who are working at Medium, so they knew how that worked, and they had a little bit of exposure to that service. The main issue with it is that, as you can see on that screenshot, the code has not been updated for almost 3 years now. And it's also not that trivial to set up, or not as trivial as Neo4j. It's a two-tier model, so it uses a Scala application backed by MySQL. And so we would have to set up all that, which we were like not too stroke about. And then finally, Neo4j. So Neo4j for us looked easy to start because, you know, to install Neo4j is basically take the tarball, put it on your disk, then do Neo4j start, and you're on your way. And it was super easy to experiment. And we liked the aspect that there was a good community when you look online for questions, or if you have questions. And that, you know, at the time we're thinking, like, how do we go to live to production if we like Neo4j, and they have on the Enterprise Edition high availability support and the ability to do backups and access to the support. Of course, we didn't like that. You know, we had to pay for it, but you know, it's a trade-off. And then we didn't have anyone who had ever used Neo4j at Medium, so it was very new for us. And the last bit of it is because, you know, it's not a managed service like DynamoDB or RDS, for example. We needed to use our own hardware, or like, you know, our own VMs and manage that too. Well, as you can guess, we went with Neo4j, and we've been super happy with it. So, a word on architecture. Medium is all service-oriented. It's a service-oriented architecture. So we have services responsible for every action of, you know, every feature of the platform, and the social layer is no exception. So we have that social service that is written in Go, and on that day we called it Go Social, a super creative name. And it uses, it's a service that talks to Neo4j, and that get all the relationship between the nodes. It uses two sources, Neo4j for everything that's graph related, and DynamoDB to fetch details on some of the data. We use the enterprise version of Neo4j, and through that the HA ability of it. So we have multiple Neo4j servers, and so in order for Go Social to talk to those to Neo4j, we use HA proxy in the middle, and HA proxy we look at the request that Go Social sends and redirect it to slaves if it's read request, or to the master if it's a write request. It's also worth mentioning we have multiple Go Social instances. Everything is highly available in our infrastructure right now. Now, in terms of schema, it's very simple right now what schema look like. We have only 3 nodes: user, post, and collection. And we have all the relationship you would expect from some kind of social network site coupled with like a publication platform. So you have relationship called, you know, followed when you follow an author, wrote when someone write a piece of content, published once it's published, recommended. I guess the best is to show you collection, because it may not be the most obvious thing. So here's a collection. A collection is like a groupment of posts, basically. So here's a collection called QPoint, edited by Jonathan, and you can see all the various stories that have been written in it. So all those stories are posts. And we can take a post. Here's a post, for example, from Elton John, the real Elton John. And so here's the author of that post. And we can see actually the entire social layer right there. So this is the author of the post. This is the post, obviously. Here are the list of people recommending that post, and this is a list. You can show more recommends, and scan through that list. And then you have more actions that you can do. Like if you like the story, you can recommend it, and you can follow the author. Yeah, that's the kind of thing you can do. And that's all those actions are then later translated into a relationship and nodes within Neo4j. That's a little bit what I'm going to demo at the end of the webinar. So productionizing Neo4j. Like I said, like we experimented for a while with Neo4j within our internal environment, and then when we were happy with what we had came up with, we were like, all right, it's time to go live to production. And so how do we do that? And that's basically where I have the most knowledge. So if you have any question specifically on that part, that's where I'll be the most useful to answer your questions. Also, just so you know, there's nothing really crazy about it. It's all very standard, apps work. But I guess, it's going to be interesting if you haven't really went to production, probably like best practice kind of slides. First thing we had to do is capacity planning. So capacity planning is usually like the weirdest thing that you have to do when you go live with a new service, because it's always really hard to decide, to guess how successful the service will be, to know how the platform will behave without, given that you can do load tests, you never really load test the actual production traffic because you don't know how people are behaving exactly until the service is live. Luckily for us, we knew how much data we wanted to have at first, because when you sign up for Medium, you sign up with your Twitter or Facebook account. And then what we do is through Neo4j, so that Go Social service, we import your social graph into Neo4j. So we kind of were able to count how many nodes we were going to have and how many relationships we are likely to get. So we had a solid idea of where to start. So we went on that at the link providing that screenshot, neo4j.com/hardware-sizing-calculator. And we're able to fill up that form and get an idea of how much hardware we needed. 6 months into the project, we then went back in the same calculator. We then had metrics on how the platform and how the service is growing. So we could refresh those numbers and see how we had to do capacity planning for the next 6 months. So it was actually about 6 months ago. So it's about time for us to do it again. And you'll see that toward the end, last slide. The next thing we had to do was the actual data import. And this was like one of the issues we had. When we started with Neo4j, it was Neo4j 2.0, actually 2.0.1 to be exact. And the problem is at that time, there was no good way to import data. Luckily for us, that guy, Michael Hunger, wrote that plugin for the shell, which allows for import. So the idea is like you create your CSV files, and then you can, through the shell, import them. As of Neo4j 2.1, I think that maybe that exact plugin or something close to it was implemented, so you don't really need anymore to worry about that if you haven't gone through importing data in Neo4j. But if you're still on 2.0, or if you don't like what you see in 2.1, you can experiment with that plugin. And the link is in that slide. Next thing is monitoring and metrics. So of course, that's one of the things you want to have when you go live with a service, is an idea of the health of your service. We don't have a real monitoring system at Medium. By real, I mean independent from our metric system. We basically have metrics for everything, and we just alert on those metrics. We use Datadog at the moment, but it's really up to you what you guys use. The important thing is to cover every aspect of your infrastructure. So here are a few. First of all, you have to monitor and graph your architecture, meaning like how many nodes you have, how many master, how many slaves. It's not too good if you have 0 master or more than 1 master too. It's not good too if you don't have at least 1 master, 1 slave, because all the writes, like the transaction is considered as successful when a write is returned to the master and replicated to at least a slave. So if you don't have that replication, you can't really guarantee that the write is done. And then you have to monitor your system. So by system, I mean your servers, so CPU, memory, disk space. Then you can monitor Neo4j. So if you don't know, Neo4j is written in Java and has a GMX endpoint with a bunch of metrics that you can look at. So here are the one we are looking at. And like I said, all that is fetched from GMX. And you can do a couple of interesting things, like you can look at how much query hits the cache of Neo4j. You can look at, how many transaction happens. Also, independently from the health of Neo4j, you want to monitor the data that Neo4j contains. So, your data set. So monitoring the data set is basically monitoring how many nodes and relationship you have, and make sure that the growth seems right, like you don't have too many relationships suddenly. Could be a bug in the code or something like that. Then Neo4j running on Java, you want to monitor Java. So you want to monitor things like the garbage collection, for example. And then finally, like one thing that you may forget, but that's kind of important, is to monitor the service, the responses from Neo4j. So we do monitor like the responses of each request that we send to Neo4j. And it's pretty much like on the web, right? Like if you get a 200, you're okay. If you get like a 400, 500 errors, that's not good. So if you have a drop in the number of 200 responses or an increase in the 404 or 500, something is not right. Log aggregation and indexing. That's something we do for all our services. Now I feel that if you're not doing it yet, it's probably not worth doing that just for Neo4j, but it's always a good practice to have a centralized location where you can get all the logs of a given service. We use that thing called ELK, that stack called ELK, which means Elasticsearch, Logstash, and Kibana. There are plenty of alternatives online. You can go for free product like this one, or you can go with solution like Splunk, for example. The important thing is like when you go live with your service, you're likely to discover some new issues that you have not really anticipated. I'll cover some in the later slides. But it's really useful when you can just go to one address and start searching like through your logs and search, in a faster way than grep and sed, and expose, obvious issues. So if you get a chance to do that, it's always good to do it. Backups, which is something that people may forget to do. We use the backup script that's provided by, one sec, sorry. We use a backup script that's provided by Neo4j, and to trigger it, we just use a Jenkins job. And what we do is we do a backup every day. And the advantage of, at least for us, to use Jenkins is that everyone can look at the logs that's been produced by the backup action. And we can discover through that if the backup has some issues. We've occasionally seen some issues, especially with the version 2.0 of Neo4j, where we had some issue with the indexing. And those are discovered through doing backups because there is a consistency check done toward the end of the backup. We store a backup in Amazon S3. And I guess the one last thing worth mentioning is that you can do two types of backup. You can do backup, like full backup or incremental backups. And to do full backup, you just create a new directory, backup in that directory. And to do incremental backups, you just keep backing up in the same directory. It's probably better to do both because that way if you have fresh copies of your backup, you can just use that and be ensured that the data is good in there. And then the last thing is whenever we encounter issues, we documented that in our runbook or playbook, depending on how you name that. And that's really useful for, when someone is paged, he has, a place to start where you can understand what the architecture is like, what are the metrics we care about, and, what are the previous issues we encountered and how we fixed those. I'm going to briefly talk about the lesson learned. So first thing that we discovered is how great the support is. Like if you have any uncertainty, if you encounter any issue or wonder about anything, just shoot an email to the support and they are really fast to respond. I once had an issue in the middle of the night. I was paged for, losing a master, and I sent an email to the support it was past midnight, and then by 1 a.m. someone in Germany had replied with really good information to the question I had. From using Neo4j, we discovered a couple of things. Some that are super obvious, or some that are less obvious. The long traversal is like what Neo4j is the best at, right? So if you're looking at who are the people that I follow, who recommend a post, who have friends who are also recommending that post, and also wrote a story from the same collection, like Neo4j will give you that in no time, while any other competing solution that's not, a graph database will time out almost before, or you will time out. You'll just give up on getting the answer. Then the where not clause is a little bit dangerous. So you can always do, a match something, where not something else, but make sure that you're looking at a subset of your graph on the where not clause, because it's an expensive operation. And we discovered that kind of like in the hard way. Luckily, I think as of Neo4j 2.1, we've seen drastic improvement on those clauses and on those Cypher queries, And I think that's because there's that new thing called Ronjas, a name like that, that's like a Cypher optimizer for when you're not writing very optimal queries. And obviously, we didn't write very optimal queries. And then the last bit is like something that is still an issue for us, is what's called dense node or super nodes. And oops, yeah. So this is not a very good representation of what a dense or super node is. A dense node is when you have too many relationships on one node. And so on my graph, I may have 50, 60 nodes with relationship toward one other node. But this is what it looks like in real life. Oops. So in real life, here's a collection called Matter that we have in Medium. And there's over 900,000 people following that collection. So if you translate that in Neo4j world, right, that means you have a node of type collection called Matter. And then you have 900,000 user nodes that have a relationship followed toward that node. So if you're interested to do any query toward that specific collection or any other super node, you're looking at a very, very long time to get an answer, especially if you're interested in something within the follower of that collection. One thing worth mentioning is to put your writes in a queue. While Neo4j is highly available, it is not always. It's kind of like eventually highly available. So all the writes only happen on the master. And if you lose your master, then you have to wait for a new master to be elected. And during that time, you're not really able to do any writes. So it's a good practice to put your writes in a queue, and that way, whenever the master is, whenever your service is healthy, your Neo4j cluster is healthy, you can perform your writes. And then tune the configuration over time. That's true for almost every data store that you have to manage. First of all, one of the issues we had when we went live with Neo4j was issues with the garbage collection. With a default option, or even with the garbage collection tuned as much as we could, we always end up having some very, very long garbage collection time of over 10 seconds. And those garbage collection, where it's like a stop the world event, make look that the service is not responding, like Neo4j is down. So if you get down your master, the cluster will figure out that the master died and proceed to a new election. But like I said, in the meantime, you're not in a very healthy state. So one trick or tip for everyone who's listening to the webinar and who's getting the same kind of issues is to change the garbage collection method. We went for G1, which doesn't have any stop the world event, and that's great. Like, we haven't had any issues with garbage collection since. And then the last piece is to talk about the Neo4j settings. So here are the main settings that you can tune inside Neo4j in the neo4j.property file. And it's really easy to tune them, because you can just look at your GraphDB directory and look at the names and match the names with the parameters. So here's, for example, the one for the Neo4j property store. So you can see, like, the map database, the mapped memory is 2 gig in our settings, and we're like now at 1.9 gig. So soon we're gonna have to increase that. And then here's the one for array. You can see, like, array mapped memory, and then the one for strings mapped memory. That's it for the slide. I'm now going to do a demo of our Go Social service. Actually, so for the demo, let's do that. One other trick I didn't mention, not trick, but cool thing that I didn't mention, is to expose the browser to everyone in your company. That's always super useful. So I created, for the sake of the demo, a new account called NatTest account. And right now, it doesn't have any relationship. So this is a node, and as you can see, it has 0 relationship. What I'm going to do now is I'm going to start playing around with the user. So we're going to search for article. Let's search for Neo4j, for example. And there's a couple of stories here that have the word Neo4j in, and plus a collection here about Neo4j. I haven't read it. I'm not sure what it has, but let's take that first story here. It's a story written by Michael Hunger. It's actually a response for how we medium went social. And I guess he's talking about, it looks like the slide it looks like the presentation that you get when you go to the Neo4j event. And I'm sure it's, because that guy talks about Neo4j, is totally a guy that's worth being followed. So I'm going to follow that author. And now, as you can see, I'm going to run the same queries as I just did. Oops, that's not it. The query that I just did, relations. And you can see that my user, which is actually that guy, is now following that author. And let's close those tabs. Getting back to that author, we can look at him in more detail. His name is Michael Hunger, and he is recommending a couple of stories. He's recommending actually 3 stories here. And so with that Go Social service, one thing we do is we use that to do a recommendation on what to read. And what we consider as a good recommendation for you is, like, if you're following an author and that author is recommending those stories, we imagine that it's something you may be interested in. So let's just perform that exact query. Sorry about that. So let's just perform that query. This is like the Go Social service that I'm calling through a curl command. All our services talk with a REST API. And I'm going to ask the post recommended by friends for the user ID of my demo. And as you can see, he's recommending 3 posts. The cool thing with posts is that it's easy for me to show you what they are, because you can do /p and the post ID. So here's the first post he is recommending. Here's the second one. And the last one. So here are the three posts that he recommended. We can see the same queries being performed actually inside Neo4j. I save that. Post recommended by friend. So here's my relationship with him, and here are the 3 stories IDs that he's recommending. As you can see, we don't have the name of the person, we just store IDs. And then if we want to look back and see what the actual username or the story title, we then use DynamoDB to get that information. Let's do that. Let's get back to his story actually here. And let's dig a little bit more into what we can do. So you can see all those faces here at the top. Here are people that are recommending that story. And as you can see, those are people I don't really know yet, like Eric, Alison, Abed, Paul. What I'm going to do is I'm going to pretend that I know a bunch of guys, like here's Matt Wright, here's Rick, and Barthélemy. So I'm now following more user, and we can see that probably by running that same queries and look at the new relationship we have, and we can see that now I'm following all those guys, and we can actually see that some of them are following each other. So you can see a little bit more like how awesome that is, because without us asking any of it, we even see that there's even more relationship right there. And one cool thing about it is, as you remember before, like the tile at the top, we had Eric, Raphael, Mark, actually I forgot, Abed was there, Paul, Shoemaker. Now that I'm following a new set of person, we discovered that, you know, while having those faces here at the top was kind of fun, it was a lot more interesting that if those faces were people you know. So what we do, in fact, is now we organize, we always do that, but before on the demo, we didn't have anyone we are following. We always put priorities on the person you're following, because that gives, you know, better, like basically we state that you don't care that much about who's following a post, except if you know those person. So now that I'm following Matt, Rick, and Barthélemy, I'm now having those faces first before, you know, since we display 4 faces, we also still get Eric. But this is one of the things we discovered from using Neo4j. And we can look again at for example, now at the same queries we're doing and looking at what our friends are recommending. And as you can see, the list is now a lot longer. There's all those guys who have been recommending a bunch of stories, and we can see that in Neo4j itself. And we now have a lot more selection to offer if you're wondering about a story to read, sorry. So let's see a little bit on the Neo4j UI how that looks like. And as you can see, like here's probably that story we started off because everyone is recommending it. But you can see that some other stories, like that story, for example, has been recommended by 2 of the person who are following. So let's see what the story is. Maybe it's going to be something about Neo4j again. No, that was running concurrent queries in GoSocial, well, which is kind of Neo4j actually. So it's totally about Neo4j as well. And it's a post from Tess who works with us at Medium. So there you have it. This is a little bit of what we do with Neo4j at Medium. And I guess now if you have any question.